Okay, so this is our last section in chapter 5. Okay, all of the formulas that you are given today will be given to you on the test. Okay, so write these down. You do not have to memorize them, but you do have to know how to use them. Okay. We will have a quiz on Friday, so this is going to be on that quiz, and since this is the last section, our test will follow on Tuesday. Okay. So first, okay, we're going to talk about multiple angle formulas. The formulas we're going to talk about are double angle and half angle. Okay, double angle. What does that sound like? I wouldn't say 2 angles. Okay, our angle inside is going to be doubled. Okay. So here are our 3 double angle formulas. Notice how cosine has a few different ones we can use. That's because of our Pythagorean identities. Okay, whichever one is more useful to us, we can use. So go ahead and write these down, and then we will talk about why they work and then how they work. Okay. Now, these are very easy to prove because we know our sum and difference formulas, right? Okay. Let's see if I remember here. Okay. I'm not going to prove all 3, but I'm going to go through a proof of one of them, and you'll see that it is very easy to prove all of these true. Okay. So we'll start with sine. Does sine sound like a good one to start with? Sure, why not? Okay. The sine of 2u. Do you agree that it is the same as the sine of u plus u? Right? 2u is u plus u. Okay. Now, do we have a shortcut for when we are adding angles inside of our sine function? Yes, we do, don't we? What is it? The sine of the first angle times the cosine of the second plus the sine of the second angle times the cosine of the first. Those are all u's, aren't they? Then there's that formula right there for me. Not too bad, huh? Not quite as intense as last week's proofs, right?
But it's on the test, or is it the choice to use these? It's like on the test, are we going to have the choice to use this formula, or are we going to have to also use the other one? You know what I'm saying?
Well, there will be opportunities that it will be better for you to use these. Okay? I proved this one to be true using the other one. Does that make sense? Okay. I would not ask you to prove something for me on a regular portion of the test. Okay. Now, cosine, tangent, those are going to go about the same, right? We still can use the sum of u plus u, right? and we can do that to prove those. Would you like to see another one? What? This one? Okay. So the cosine of 2u is the same as cosine of u plus u. Okay? Our cosine is cosine u cosine second angle minus sine of the first angle sine of the second angle, right? So this is just cosine squared u minus sine squared u. How do we get that? Okay. Now how do these other ones come about? With our Pythagorean ones, right? Cosine squared is the same as 1 minus sine squared, which is why we have the 1 minus 2 sine squared up there. Okay. And I can do the same with the other one. Okay, so let's use them. Okay. There will be times where you will need to use them to solve an equation. If you notice this equation, we're set to 0. That's great. There's nothing in common to factor, is there? I believe there's a 2. That's not going to help us very much, is it? No. Okay. So instead, I see that this has angle x and this has angle 2x, right? Can I do something to the sine of 2x? Yes, Mrs. Holman, we can. What is the sine of 2x the same as? Okay. So we're going to use x's instead of u's. That is the formula we just talked about. Okay, that's our double angle formula. So now we have an equation that looks like this. 2 cosine x plus 4 sine x cosine x. Now, is there something in common? There is 2 in cosine, right? So I'm going to factor out 2 cosine of x. Left over would be 1 plus 2 sine of x, right? Okay. Now what do we do? We have a product that equals 0. Okay. Each of them equals 0. When is the cosine equal to 0? Pi over 2 plus 2 pi n. And when? And 3 pi over 2 plus 2 pi n. Okay. This is one of those times. How far apart are our solutions? These are pi apart, aren't they? Okay. So if you gave me this as a solution, you would be right. You could also consolidate it to be pi over 2 plus pi n, which is what you would see in the back of your book. However, if you leave it as these two, it is fine. Okay? So if this makes you panic a little bit, you can leave it as the 2. If you see that you can consolidate them, go and go for it. Okay. All right, let's go over here. Here we have the sine of x equals negative 1/2. And when does that happen? Not everybody all at once. Not quite. Because it's negative 7 pi over 6. And 11 pi over 6. We cannot, these are not pi apart. Okay, only when they're pi apart can we consolidate. Okay, so you would need both of these solutions. Okay. All right, so in your equations, if you have one function that has just x or theta as an angle, but you have another function with a double angle, you want to go ahead and change it so they're all consistent. Okay? So look for those opportunities in your equations. How else can we use them? Here I'm giving you that cosine is, the cosine of theta is 5/13, and this is telling me it is in the what quadrant? Fourth quadrant. But I actually want the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. What can I do to get those? Do we know the sine, cosine, and tangent of theta? Could we get them? Okay. How could we get them? What am I doing? I'm drawing a triangle, aren't I? In the fourth quadrant, theta has a cosine ratio of 5/13. What is this third side over here? 12. And I'm going to label it negative because we are below the x-axis. Okay. So if I want the sine of 2 theta, okay, I can't just double the sine ratio. Okay, that's not how it works. I don't know how big theta is to begin with. All right. But what we can do is we know that sine theta is 2, sine of 2 theta, excuse me, is 2 sine theta cosine theta, correct? Which means the sine of 2 theta would be 2 times, what is the sine of theta? I can go back to my picture, and what is that ratio? Okay, negative 12/13 times our cosine, 5/13, right? So the sine of 2 theta is negative 120 over 169. What about the cosine of 2 theta? I know theta, right? So we can cosine, the double angle formula for cosine has 3 different options, right? Which one would you like to use?
I like the cosine squared u minus sine squared u.
Okay. So the cosine of 2u is the same thing as cosine squared of theta minus sine squared of just theta. Okay. Luckily, we know what those are, right? The cosine of theta, when we look at our picture, is 5/13 minus the sine of theta is negative 12/13. And we have to square it. So now we're just subtracting fractions. Here we have 25 over 169 minus 144 over 169. What is that? And it would be negative, right? All right. Now we need the tangent. Okay. What do you want me to do to find the tangent of this angle?
There's only one way.
There's not only one way. Why is there not only one way?
Because you could just take the fraction here and
Tangent is what quotient? Okay, so could you use the double angle formula? Yes. Or you could say, well, sine is negative 120 over 169 divided by cosine is negative 119 over 169. And that would divide to 120 over 119. So if you have to find all three, you don't have to use the double angle formula for all three, but you could, right? All right. Question: what quadrant does angle 2 theta lie in? The third. We know that because tangent is positive, the other two are negative. Okay? We only know that based on our answers. We don't know that before. Okay? Because we don't know how big theta is to begin with. Okay? Questions so far? Our half angle formulas are these. Okay, now you see with all three of them, there is that plus or minus. We have that plus or minus because when we cut an angle in half, we have to be careful which quadrant it is going to be in. Okay? So we pick the plus or minus based on our knowledge of the angle and which quadrant the half angle will lie in. Okay. we're just gonna do one example with these. Really only with angles that we actually know, like they have a degree value. I'm not gonna give you arbitrary angles like theta, okay? So what we are going to work with is the angle 165 degrees. Okay, so we're going to find the sine, cosine, and tangent of 165 degrees. Okay, now I just gave you half angle formulas. What angle that is special could we cut in half to get 165 degrees? What number do we cut in half to get 165? 330. Is 330 a special angle? It sure is. Okay? So if I want the sine of 165 degrees, then I can say, all right, well, that's the same thing as 330 cut in half.
Please pardon the interruption. At this time, teachers, please release those 12th graders who were selected to participate in the NAEP Section A testing. Seniors that have been selected, please report to the library at this time. Thank you.
Okay? So if we have the sine of a half angle, right? Then it's the same thing as plus or minus the square root of 1 minus the cosine of u all over 2. Right? Now, am I going to choose the positive or the negative? Hold on. What angle are we evaluating? 165, that is where? Second quadrant, is sine positive or negative? It is positive. Okay. What is the cosine of 330 degrees? Square root of 3 over 2. Okay. So from here we get to do some fun simplifying, right? Not a big deal. In our numerator I have a fraction. So let's make our entire numerator a fraction. So 1 is the same thing as 2 over 2, correct? So I can change it to 2 minus radical 3 all over 2. Now, dividing by 2 is the same thing as multiplying by 1/2. So this would be the square root of 2 minus radical 3 all over 4. Now, the only thing that I see that we can do is we can break a radical up by division. Okay? What's the square root of 4? 2. So we can write this as radical 2 minus radical 3 all over radical 4, which is 2.
Radical or 2 times radical 3 or 2 times radical?
2 minus. Did I say times?
No, but you wrote times. It kind of looks like the square root symbol.
Sorry, that is a minus.
Because in the book, when you see them write the square root symbols, they always write with that little fuck after it too.
Yeah.
It's always fun for me to do that.
I'm sorry. Okay. Now, for our cosine 1, right? The cosine of 165 degrees, we can think of as cutting 330 in half, and that is plus or minus the square root of 1 plus cosine of u over 2. Okay. Now, 165 degrees in the second quadrant, is our cosine going to be positive or negative? It's going to be negative. So we have negative square root of 1 plus radical 3 over 2 over 2. And this is going to simplify similarly, isn't it? We can combine our numerator. Okay. When we do the division, we're multiplying by the reciprocal. And then, since we have a 4 in the denominator, we can actually simplify that radical.
Wait, how'd you get the negative again? Outside the square root?
Since 165 degrees is in the second quadrant, the cosine needs to be negative. Okay. Now, you could take sine over cosine, excuse me, to get tangent. I would not do that here. I would use your half angle formula for tangent. Otherwise, you're dividing radicals inside of radicals. Does that sound enjoyable to you? It doesn't even sound enjoyable to me. Okay, so use the half angle formula here. Okay, let's see, do we have time to do that quick? Tangent of 165 degrees is the same thing as tangent of 330 over 2, which would be plus or minus the square root of 1 minus the cosine of 330 over 1 plus the cosine of 330. Okay. Is our tangent going to be positive or negative? Negative. Okay. Okay, I'm not going to simplify that. I want to talk about your homework real quick. Okay, whoops. Because it's Wednesday and we're robbed of some minutes. Here is your homework. I do want to give you a warning. Okay? Your book is going to ask for, some of them will ask for solutions between 0 and 2 pi. Okay? Now, if you are solving, and let's say that you have a double angle equals pi over 2 plus 2 pi n, you've seen a solution that looks like that, right? Which means that x is pi over 4 plus pi n. If they ask for just the solutions between 0 and 2 pi, pi over 4 would not be your only solution. Right? What would be another solution from this? Okay. If we're adding pi n every time, then we would also have to include 5 pi over 4. Okay. So when you have these times where you have to give solutions just between 0 and 2 pi, please be careful. My assignment is different. Oh. Then, hold on. If my assignment is different, don't leave me yet. Don't leave me yet. If the bell rings, don't leave. Let me check this. You have less problems. Sorry. Do you want those problems or you want me to keep that up there? Okay. Thank you, Sarah.